Surface area. Topic 18-2 from Envision Math 6. First, we need to define what it means for the surface area of an object. It is the total area of the surfaces of the 3D object. So if you're looking at this box here, we are talking about the bottom, the top, and every side going around the object. In this example, they say Rufus wants to cover a shoebox with decorative paper to make a storage box for his photos. And they want to know how much paper will he need to cover the box. Well, the amount of paper he needs to cover that is the surface area of the shoebox. Nets are used quite often to help people find the surface area of an object. A net is the 3D object unfolded, and if you look closely, we can match the parts of the 3D object to the unfolded net. I'm going to start with the top and the bottom of the box. The top is 10 inches along the side and 8 inches along the back. This would also be 8 inches here, and this edge would also be 10 inches because they are parallel to the back, or they're opposite edges, so they have the same measurements. I'm going to label this A. There are two of them on the top and another one directly on the bottom. And the dimensions are 10 by 8. Next, I've got a side piece here. This would again be 10. And then that edge is 6. I'm going to label this part B. There's two of them, the one in front and one directly opposite of it. And those dimensions are 10 by 6. And my last piece, I'm going to label C here. This edge is 6, and then we saw that the top edge of that was 8. So it's C, and two of them, one in front, one directly opposite of it, and we have 8 by 6. Now I'm going to find the area of each of those sections. So the 10 by 8 was 80, but I have two of them, so that means I have 160. And then the 10 by 6 is 60. Two of those gives me 120. 8 times 6 is 48. Two of those would give me 96. Then to find my total area, I simply need to take and add all of those together. When I add them all together, I get 376. Now we can't forget that this must include some units. And in our original drawing, it shows 10, and it shows those two little lines like that by the 10. That is actually notation for inches. So we would have 376 inches squared. I'm going to go through the same procedure with this triangular prism to find the surface area. First, I'm going to find the three edges of the triangle itself. I have a 9 centimeter, a 12 centimeter, and then this diagonal piece right here is labeled as 15 centimeters. The first face I'm going to list will be this triangular base. I'm going to label it A. I have one in the front and one in the back that are identical. So I have two of them labeled A. And they are 9 times 12, but we must remember, since this is a triangle, I also need to divide that measurement by 2. However, because of our knowledge of inverse operations, I know if I multiply something by 2 and then divide it by 2, I've actually undone that operation. So I can get rid of this multiplying by 2 and the dividing by 2 because they're just going to undo each other. And that's going to leave me with 9 times 12, which is 108 centimeters squared for those 2 triangles, which would basically be the area of 1 square. My next piece is going to be what I've labeled here as B. There's only one of them, and it is 9 on one edge times 18 along that top edge. That equals 162 centimeters squared. The next piece I'm going to look at is the bottom. I'm labeling it C, and it is 12 on one edge times 18 on the other edge, and there is one of them. 12 times 18 ends up to be 216 centimeters squared. And my last piece, which I've labeled D here, is the front or side piece of this prism, and it's measuring 15 on one edge by 18 on the other edge, and that equals 270 centimeters squared. Now I simply need to add these measurements together to find the total area of all the surfaces of this triangular prism. That total ends up being 242 centimeters squared. Now there's something I want you to notice about the dimensions that we used for this triangular prism to find the surface area. We had the original face of the triangle, which was this 9 times 12. But then each one of the edges, the 9 centimeters, the 15 centimeters, and the 12, here's our 9, our 12, and our 15. So each one of these edges of the triangle was multiplied by the thickness or width of this triangular prism. So you basically have the bases and then each edge of the triangle multiplied by the thickness of the prism. Now we're going to label the parts of the pyramid. I'm going to start with this base, and I'm going to label it A. And there's only one of them, and since it is a square pyramid, that means each edge here is 3 inches. So that gives me 3 times 3, which would give me 9 inches squared for the base. Now we're going to look at the sides of the pyramid. And since it's a pyramid, each one of these triangular sides are going to be identical because it's a square pyramid. So they're all 3 for the base, and they're all going to be 5 for their height. So we have 4 of them, and they are 3 times 5. But we know triangles, we do 3 times 5 divided by 2. I'm going to use a little bit of algebra here to simplify this. 4 times 3 times 5 divided by 2. I can cross multiply here because both 4 and 2 are divisible by 2. 4 divided by 2 is 2, 2 divided by 2 is 1, which is going to leave me with 3 times 5 is 15 times 2, which is 30 inches squared. So my total for that will be 39 inches squared for all of the surfaces of this square pyramid. Now you try. I've actually labeled the faces of your first one, this parallelogram prism. So you're going to have a top edge and bottom that are the same, the parallelogram on the front and back that are the same, and then this edge C here is actually just a rectangle, and there's also 2 of those. See what you come up with? Hit pause on the video, and when you hit play again, the answers will appear. Okay, for the first figure, face A is 4 times 4. 2 times 4 is 8 times 4 is 32. Face B is a parallelogram, so we do the base times the height, which is 4 times 2. 2 times 4 is 8, times 2 is 16. And then face C is just a simple rectangle, 4 times 2.5. 2 times 4 is 8, times 2.5 gives us 20 meters squared. When we add all those faces up together, we get 68 meters squared. Now go ahead and try the triangular prism. Again, hit pause on the video, and when you hit play again, the answers will appear. The first face A is the triangular base and top. It is 3 by 4, where they form a perpendicular intersection. There's 2 of them, so it's 3 times 4 divided by 2, but since multiplying by 2 and dividing by 2 would undo each other, I canceled those out, and it would just give me 12 meters squared. Side B is 3 at the base and 6 high, which is 18 meters squared. Side C, there's only one of them. It's 4 by 6 meters, which would give us 24 meters squared. And there's one more surface on the back side here, which is 5 by 6. So when I multiply that, that gives me 30 meters squared. When I add them all together, that gives me a total of 84 meters squared. Now go ahead and do your quick check and see how well you understood today's lesson.